Welcome in everybody to another lesson. So first off, if you're seeing me, yes, I did shave my head bald. I do this every time of year around this time of year because I like to have cooler hair for the summer. So some of you may be seeing me as quite a shock. So yes, I did shave my head bald. So sorry about that, but anyway, so today we're going to we're starting our fractions unit. And today's going to seem largely like a review of basic math, but it is necessary because, again, pre-algebra, the goal is to tie in basic math with new stuff. Because once we get to Algebra 1, we pretty much don't review basic math anymore. It's assumed you know it by then. So, we're going to today convert fractions to decimals, and we'll do some inequality problems with fractions and decimals also. So, let's start out with, let's say we have something like 1/5, okay? We got the fraction 1/5. We can convert it to a decimal. I don't even need the calculator. I could tell you that's 0.2. We would get 0.2 for our decimal answer, right? You can use your calculator. You're welcome to use it. If you're looking for how to convert fractions to decimals more in depth with doing the actual division to obtain it, I did cover that in Basic Math 1. You can find the videos there. Since we're in pre-algebra, I don't see the need to do that. We just use our calculator, but I did cover the longer way in Basic Math 1. Okay, we have 7/20ths, right? 7/20ths, this may not be as obvious. Of course, if we recall, you want to convert your denominator of 20 into 100, so you'll have to multiply that by 5. 20 times 5 is 100, which means we got to do that to the numerator. So that means 7 times 5 is 35. So the answer you should get, since you have 35 out of 100, is 0.35. You would get 0.35 for 7/20ths. Alright, now we have a negative fraction here. So we have negative 8/25ths. Negative 8/25ths, well, of course, the negative sign just hangs out. Let's pay attention to the 8/25ths. 25 in the denominator, we can make that into 100. In order to do that, we got to multiply by 4. But what you do to the denominator, you got to do to the numerator. That would give you 32 in the numerator, so your answer should be negative 0.32. You should get negative 0.32 for your decimal answer. We have negative 5/8, which I know if we punch in the calculator, we're going to get negative 0.625. So you would get negative 0.625 for negative 5/8. Alright. Now how about this one here? We have 7 3/10. So we have a mixed number. Well, we have 7 3/10. Of course, you're going to keep the whole number 7, just focus on the 3/10. 3/10 will give you 0.3, so you'll have 7.3. Your answer to this is 7.3. One and a half, we should know that by now. 1 1/2, that's just going to be 1.5. 1 1/2 is 1.5. Alright, negative 5 and 1/8. So of course you'll have your negative 5 to start with, then some decimal point, and then what's 1/8? That's 0.125. So the answer you would get is negative 5.125 for negative 5 1/8. So yeah, we can use a calculator. We can convert decimals all day. But let's do some inequalities. See if my blue one writes. Alright. Is the first number greater than, equal to, or less than the second number? Alright, so is the first number greater than, equal to, or less than the second number? Well, let's start out here. We have 0.3, then we have 1/4. So you have a decimal, then a fraction. They want to know, is 0.3 going to be greater than, equal to, or less than 1/4? What I would do, of course, in the second step, 0.3, keep that. I would convert 1/4 into a decimal. 1/4 is 0.25. All of a sudden it becomes clear. 0.3 and 0.25, well, 0.3 is definitely greater than 0.25. So you'll make a therefore statement. Therefore, 0.3 is greater than 1/4. You want to make sure you put it back in the original form once you've arrived at what your answer is, the greater than. So therefore 0.3 is greater than 1/4. Alright. Alright, so then we have 5/8. They give you 5/8 and they give you 0.65. So you got 5/8 being compared to 0.65. Is 5/8 greater than, equal to, or less than 0.65? Well, again, I would convert that 5/8 into a decimal. So 5/8 as a decimal is 0.625. Yes, I actually do know some of these in my head because I've used them so much. I don't know all of them, but there are times I still got to pull out a calculator. But yeah. But 5/8 as a decimal is 0.625. So is 0.625, is that greater than, equal to, or less than 0.65? Well, it's going to be less than. It'll be less than 0.65. So what you would now do, since you've come up with what it is, you'll make a therefore statement. You're going to have the original inequality. Therefore, 5/8 is less than 0.65. That's what you would say. 5/8 is less than 0.65. I'm sure some of these have come up decimals compared to fractions. That's when it can get tricky. Alright, we have 2/5. Then we have 0.4. We got 2/5 and 0.4. So once again, since you have a fraction, I would say convert that 2/5 to a decimal. Well, what do you know? 2/5 actually happens to be 0.4 itself. It's pretty clear that 0.4 equals 0.4. So you would make your therefore statement and say that 2/5 equals 0.4. So therefore 2/5 equals 0.4. now we have 0.3, and then you have the fraction of 1/2. So you got 0.3 and then 1/2. Well, what you want to do, of course, convert that 1/2 to a decimal. So 0.3 will be stacked up against 0.5, because 1/2 is 0.5. Well, it's obvious that 0.3 is less than 0.5. So you would say, therefore, those three triangle dots, those three dots arranged in a triangle pattern mean therefore. So therefore, 0.3 is less than 1/2. Alright, so yeah, 0.3 is less than 1/2. Here's some good ones. We have 7/8, 7/8, and 8/9. So we have two fractions. But it still might help to convert them to decimals. 7/8 is going to be 0.875. 8/9 I know off the top of my head is 0.8 repeating. If we recall from basic math, whenever you have a repeating bar above a number, that's the same as the 8 just keeps going infinitely, forever and ever. So it'd be 0.8888888 da 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 forever. So is 0.875 greater than, equal to, or less than 0.8 repeating? Well, it's going to be less than. So you'll make a therefore statement. Since you've arrived at what your inequality is, you'll say that 7/8 is less than 8/9. So 7/8 is less than 8/9. Alright, so we have 5/7 and 10/14. 5/7 and 10/14. With this particular one, I don't think we're going to have to bust out any decimals. I'm going to tell you why. Because it almost looks like 10/14 is double the numerator and denominator. Let's prove that. So you'll have 5/7 compared to, what are some factors of 10? Well, that'd be 5 and 2. So you have 5 times 2 over, what are some factors of 14? Well, 7 and 2. Well, what do you know? You have, in the numerator and denominator, you have a common 2 that'll cancel out. You're left with 5/7. Well, 5/7 clearly equals 5/7. So you would say, therefore, 5/7 equals 10/14. 5/7 equals 10/14. Since 5/7 equals 5/7, it definitely equals 10/14. Okay. Now we got some negatives. We have -1/8 compared to -1/10. So we got -1/8 compared to -1/10. Well, it's important, I would say, convert these as decimals. -1/8 is -0.125. -1/10 is simply -0.1. Now, it's important to remember we're working with negative numbers here. They're both negative. If these were positive, for sure the 0.125 would be greater if they were both positive. But remember, when you have both numbers being negative, the bigger number is actually less than the smaller number. It works in reverse with negative numbers. So negative 0.125 is actually less than negative 0.1. So therefore, negative 1/8 is less than negative 1/10. So negative 1/8 is actually less than negative 1/10. All right. We have negative 6/25, and then we have negative 1/4. So we got negative 6/25 and negative 1/4. Well, negative 6/25 as a decimal is negative 0.24. You want to convert these into decimals. Negative 1/4, that'll be negative 0.25. So now we have got to answer, is negative 0.24 greater than, equal to, or less than negative 0.25? Well, since the numbers are both negative, it goes in reverse. The bigger the number, the smaller it actually is. So negative 0.24 is actually greater than negative 0.25. Since they're both negative, it goes in reverse. So you'll say, therefore, negative 6/25 is actually greater than negative 1/4. So yes, negative 6/25 is greater than negative 1/4. All right, I got 4 more here. I think we can do it. 4 more. We got 1/5. Then we have 0.5 with the bar over the 5, meaning that the 5 repeats infinitely. Well, what we got to do, of course, convert the 1/5 into a decimal. That'll be 0.2. Then you'll have 0.5 with the bar repeating. That means that the 5 just keeps going on infinitely. So, is 0.2 greater than, equal to, or less than 0.5 with the bar repeating? It should be pretty clear it's less than. So you would say, therefore, 1/5 is less than 0.5 bar. That one should have been pretty obvious. Three more. So we have 1 1/20, and then we have 1.01. Okay. Well, of course, convert your 1 1/20 into a decimal. Start out by, of course, you'll have 1 point, whatever 1/20 is. So 1 point, and then what is 1/20? That'd be 0.05. So now you have 1.05 and 1.01. Is 1.05 greater than, equal to, or less than 1.01? Clearly it's greater than. So you'll say, therefore, 1 1/20 is greater than 1.01. All right, 2 more. We have 3 4/9, and then we have 3.4 with the bar over the 4. Well, what you want to do, of course, you have 3 and 4/9. I would convert that into a decimal. So you'll have 3 point, what is 4/9? 4/9 would actually be, I'm pretty sure that's 0.4 repeating. Let me double check myself, but I'm pretty sure 4/9 is going to be that 0.4 repeating. Well, what do you know, it is. So then you have 3.4 repeating and 3.4 repeating, which should clearly show you these are equal. So therefore, 3 and 4/9 is equal to 3.4 repeating. Boom. And we got one more. So we have 6.18. Then we have 6 1/5. So we got 6.18 and 6 1/5. Well, I would convert that 6 1/5 into a decimal. So you'll have 6.18. Now the 6 1/5 means you'll have 6 point something. What is 1/5 as a decimal? It's 0.2. So you'd have 6.2. So now we have 6.18. Is it greater than, equal to, or less than 6.2? Clearly it's less than. So then you would say, therefore, 6.18 is less than 6 1/5. So with these inequalities, it's just knowing how to convert fractions into decimals and then just figuring out which one's bigger. But remember, with negatives, it's reverse psychology. The bigger the number is in the negatives, the smaller it actually is. So if you can just remember those, you got this. But next lesson, we're going to go on to the whole set of rational numbers. You're actually going to learn how to convert a repeated number into a fraction, and we'll also convert other decimals into fractions too that we already know how to do. But this is leading into something bigger here, because in a couple lessons we'll get back into some variables and do fractions with variables. So hope everybody has a good day. Take care.